Okay, as promised, the solutions to the next four examples that you started on yesterday at the end of class. We had started example number 5. So it says that you're on your porch and your friend goes by. So we had already set up the givens. The friend's 3 meters per second is the average speed. You're at rest, but then you begin to accelerate. And so for the friend, the delta d of the friend is just going to be v av delta t. And your delta d is going to be vi delta t 1/2 a delta t squared. But your vi is 0. And what you know is that you and your friend are here at one point, and then some other point in time, you're together up here. So for both of you, the times are the same, and the delta d's are the same. So we can set delta d of the friend equal to delta d of you, which means v av delta t will be equal to 1/2 a delta t squared. Now, you have a t term and a t squared term, and you might think, quadratic, but it really isn't, because you can divide both sides by delta t to get rid of one of them. And so then that'll just leave you v av is equal to 1/2 a delta t, and now solve for t. Multiply both sides by 2, divide by a. And so delta t is equal to 2 times, 3 meters per second over 0.3 meters per second squared. So 0.3, that's like a 10, so I think you're going to get 20 maybe. Did I do that right? 6 divided by 0.3? I think so. Just hate to do it wrong when none of you were here to tell me I screwed up. So 20 seconds. Question wants to know how far have you traveled, so then go over here and fill it in. So 1/2 times 0.3 meters per second squared times 20 seconds. 20 seconds squared is 400. Half of 400 is 200 times 0.3. That's like 3 times 20. And so that should be 60 meters. If you do this one, 3 meters per second times 20 seconds, and weirdly enough, that is also 60 meters, which means you did it right. All right, number 6. Number 6 says 2 cars are traveling 18 meters per second, but one's behind the other. So here's one car. Here's the other car. So we'll call the car in back car 1, the car in front car 2, or other way around. 2 cars are traveling. One is 40 meters behind the other. So this distance is 40 meters. After some time, the one in behind decides to accelerate. Okay, and so it catches up. So at some point up here, the 2 cars are in the same spot. Okay? This, then, if number 2 is the lead car, then this is delta D2, and this is delta D1. Okay, if we write our givens, so VI of number 1 is 18 meters per second, and VI of number 2 is also 18 meters per second. The one behind decides to accelerate, so A1 is 4 meters per second squared, and A2 doesn't like it, so it also accelerates. It's 2 meters per second squared. How are the delta D's connected? Well, delta D of 1, the guy in behind, has to equal delta D of 2 plus the 40 extra meters. This is the most common mistake. People always want to add 40 meters to the behind one, but look how far it's traveling. It's already traveling farther than number 2. The one in front is the one you have to add the 40 meters to so that they end up being equal, because the one in behind is actually traveling 40 meters more than the one in front. The delta t for number 1 will be vi delta t 1/2 a delta t of 1 squared, and the delta t of number 2 will be vi delta t 1/2 a delta t squared, and that's a of 2. This whole thing goes in where d2 is. This whole thing goes in where d1 is. So it's just like example number 4 that we did yesterday in that sense. So it'll be vi delta t 1/2 a1 delta t squared will equal vi delta t 1/2 a2 delta t squared plus 40 meters. The times will be the same. Now this might look really awful, but it's not that bad because this vi delta t and this vi delta t are both 18 meters per second times t. They're the same terms. So when you bring them over, they're going to cancel out. So you can actually just get rid of them. And so then it becomes 1/2 a1 delta t squared minus 1/2 a2 delta t squared equals 40 meters. And then you could factor out your t squared. So you'll have 1/2 a1 minus 1/2 a2 equals 40 meters, and then divide by the bracket. So t squared is equal to 40 meters over 1/2 a1 minus 1/2 a2, and now fill your numbers in. Okay, so I'll let you finish that one on your own. Let's flip to the back side. The back side is things falling and things being thrown up in the air. So the first one's being thrown up in the air. So you throw a ball upward, it passes a window 4 meters above the ground. So usually when I do these ones, if it's going up and down, then I draw it up and down. And so it says it passes by a window that's 4 meters above the ground. So this is below the window. And then this is the window. So below the window, delta D is 4 meters, and that's up. Okay? The window is 1.8 meters tall, so up here, this is 1.8 meters. That's also up. It takes 0.6 seconds to go by the window, so the delta T of the window is 0.6 seconds. What is the initial velocity with which you threw it? You want to know what is VI down here. Well, the other thing we know is A. It's 9.81 meters per second squared down, and it happens to be the same for the window piece, 9.81 meters per second squared down. Okay? So then the question is, what is it that connects these two parts of this question? Above the window and below the window. And if you remember from grade 11, it's the V's. The VF for below the window becomes the VI of the window. So if you had one of them, you'd have the other. So look at what you have on the top. You have A, delta D, and delta T. You should be able to find your VI. Once you have that VI, then it'll give you the VF, and you'll be able to find the VI for below the window. So starting with above the window, and you have delta D, VI, delta T, A. So you're going to use delta D is equal to VI delta T 1/2 A delta T squared. And you want to rearrange for VI. So subtract the 1/2 A delta T squared. And then divide by the delta T. So it becomes VI is equal to delta D minus 1/2 A delta T squared over delta T. Now be careful here. You have to watch your positives and negatives because gravity is acting down, but the object's going upward. So you gotta call one way negative, and usually it's down. So going up, and it was so it's 1.8 meters minus 1/2 negative 9.81 meters per second squared times 0.6 seconds squared over 0.6 seconds. Okay, and you're going to get your VI. Once you have this VI, then it becomes the VF of this section. And now you want to solve for your VI below the window. And so you'll have your VF, you have your delta T, you'll have